Hello, Bida. Hello, everyone. Good day. Oh, it's nice being here, and I'm very happy to see every one of us. Um, First off, I would like to apologize for not being there in person. I actually planned to do so, but as God will have it, I couldn't able to make it. Um, with that, we like to do a shout out to our organizer for bringing us together, for giving us this platform to network with each other and see each other once more and be able to learn from each other. Um, Due to the fact that our virtual session somehow, no matter how interesting it is, somehow gets boring and every other thing that comes with it. We'll try as much as possible to make this one very short and very impactful, hopefully. And basically, I just need us to just pay attention within the short period of time that I'm going to use with us. I would like to promise us that it's going to be and a very interesting one, and we will not regret paying attention at the end of the presentation. Trust me. I am Rasheed Mudasiru, and I'm a Google Cloud innovator. As a Google Cloud innovator, what we do basically is we advocate for Google Cloud products, advocate for Google Cloud service for businesses, personal use, and research. I'm a DevOps engineer, so I engage in helping um, startups to leverage on DevOps culture and implement DevOps into their system, basically, or into the teams that they are building up. I'm a GitHub campus expert. Seeing that, you'll be like, "Oh, is this guy student?" Yeah, I'm a student. I'm a computer science student at Bida University of Technology, Mina. And most of my free time, or let me say, most of my times, I find myself building community. So I'm a community developer. Um, because of my time, I don't have the time of mentioning the community I'm part of and every other. So if you want to know more, you can check out my Twitter handle at IBN underscore MUDATHIR. So you can send me a DM. I'll respond to your messages and every other thing that you need to ask or that you wish to ask me, basically. So if I'm not doing community, find myself in doing engineering role, like okay, writing my JavaScript, probably sometimes writing Pythons and for automation and every other uh tools that we use in automating tasks. And so that's a bit about myself. Um, our topic of discussion this today basically is monitoring and observability, a tool in GCP for DevOps. Seeing this will be like kind of um jargons in the topic, or what does monitor, what are we monitoring, uh what are we observing, what's DevOps. Some of us may have that question in our mind. Looking at the picture on the right hand side of our screen, uh if you know the person on the picture, you an observability tool, you can observe. Nice, you can see that. And if you have ever come across that picture somewhere and right now you can remember where you've seen that picture before, you're a monitoring tool. I don't want to call you a monitoring spirit. Okay, so what is DevOps? So in the past, what organization do is basically have two departments: the development department, which comprises of programmers. Basically, most of the development department, most of the people that you find there, or the kind of people that you find there, are the programmers. They are the people that will write the programs for the application that the company will be running on, probably the services the organization is providing for customers to use. If you want to see the people behind that code that is running, that the application is running on, you go to the development department. This development department work in the silo, they work on their own, but then we still need another set of department, or another department, or a group of people to ensure its reliability. That's where the operations team comes in. The operations team are the group of people that will ensure that, okay, the system or the application built by the development teams are up and running. They are reliable for the customers. There's no downtime. There's no issue with the application in production. So seeing this, we will see a kind of relationship between these two team, the development team and the operations team. But then in the past that I'm narrating this scenario for us is okay, there is a disconnection between them, but then the operations team cannot do anything without seeing the code or the right thing from the development team. So that's how DevOps philosophy or principle comes up, that okay, let's remove the barrier between the development teams and the operations team and make them and ease their collaboration and ensure that okay, they have a kind of a design way of working such that the development team and the operations team can work in hand and solve problem without having too much problem. So according to my definition on my according to the definition on my screen, they said DevOps refers to a series of principles. Why some people say it's not just a series of principles, it's a philosophy on its own, and what it does basically to help increase the collaboration and efficiency between the development team and operations team. So I've mentioned that to ensure collaboration between the operations team and the development team. That is the main goal of, and that's the main philosophy behind DevOps. So team at Google, they come together and be like, okay, let's have objectives, let's have things that we need to be following, that we need to be expecting when we want to implement this DevOps culture into any organization or into our own organization. And they come up with these 5 objectives. Number one of them is reduce silos. Okay, we know in the past that I narrated just a brief ago, the operation team working differently, the development team working differently. We want to remove that silence from them. I don't know, maybe that's an English word, but then we want to remove that barrier between them. We want to combine them together. We want to ensure a very good collaboration between them. So different departments that have to work together to make one things work. Let's bring them together. Let's remove the silo. Let's remove the barrier between them. Let's ensure collaboration among them. So that's the first thing. The second thing is accept failure. If you are very conversant with DevOps, or you've been hearing about DevOps, you'll be hearing failure is normal. So we know the computer that we are using at a point, there may be failure, there may be downtime, your system can be hanging. Even now that we are doing a virtual meeting, the network can go off. So we must know as a DevOps engineer or as a people, an organization adopting DevOps cultures, we must know that a failure is paramount and we must accept it, like accept failure as normal. That's the second objective of DevOps. And the third one is implement gradual change. If a feature is being released gradually, it will be very easy when there is issue to roll back the problem and be able to generate to correct the error very easily, compared to having the whole application or the whole system bundled together, push it in the production, and everything scatter. And at the end of the day, we were unable to for us to be able to fix that problem, we have to take the whole application back to the development team. But if you are adopting DevOps culture, we'll be able to and we are going with this third objective, which is to implement gradual change. We'll be able to see a kind of feature that have problem, and customer will still continue enjoying the feature that is up and running and good. So leveraging tooling and automation. The fourth objective is if everything that is the organization run manually, the DevOps objective or DevOps culture, what it comes to do for us is to help us automate those processes. Every processes that is manual, DevOps is coming for us to help us automate it. So that's the fourth objective. And the fifth objective is measure everything. They will say, if you can how can you measure its success? If you can how can you say you are successful if you cannot measure it. If you cannot measure where you are yesterday and today, you cannot say, okay, I'm better than yesterday. So measurement is crucial for your application and for the system you are building. So that's the fifth objective of DevOps. So imagine you log on to a website and what you get are these errors, be it 503 error, service not available, bad gateway, and every other error that we can think of. At that point, you'll be thinking of a contact button to notify the engineers or the organization that is giving you this service. But then imagine you seeing this, but the development teams are not seeing it. The operations team, they are not aware of this. So that's why our discussion today is very important. We want to show us that, okay, before you get this as a customer, we want the development team and the operations team to be aware that, okay, something has gone wrong, like the application that we are working on or the application that we are giving to our customer is not up and running. And that is where monitoring and observability tools comes in. The second place where this one comes into play is basically um, to manage our cloud usage. According to a research by RiseScale, they said they got it from Flexera, and they confirmed that wasted spending calculated by the company itself was around 27, and in the real sense it was 35%. And if you do the math there, you see a bit of not some a difference between the calculated self-estimated spending and the original estimated wasted spending. So basically, to be able to control your spending on cloud that you are using, you need to set up the right observability tools and the right monitoring tools. Um, if you have not been listening this morning, at this point, I want you to listen to these three things that you should go home with it. That you cannot correct what you cannot measure. If you cannot measure it, you cannot correct it. If you cannot correct it, that means you are unable to measure it. So for you to be able to correct anything that happens to your system, to your application, you should be able to measure it. For you to be able to measure it, you have to keep track of what is happening. That is, keep you need to monitor it. You need to monitor that. And the second thing is direct observation of failure leads to quicker rectification. So if no matter who you are, you're a genius, you are somebody that is very good. If you cannot identify the problem, you cannot rectify it. So direct observation of failure leads to quicker rectification. That is where observability comes into play. You need to observe what is happening to your system so that when issue comes up, you'll be able to rectify it very quickly. And the last key thing that I want us to go with is from the Dora team. The Dora team are the DevOps research team, which carry out research every year. So they said good monitoring is a staple of high performing teams. So if you want to have an high performance team, you need to have a good monitoring to set up for your system and for your team. So GCP monitoring and observability tools. What are these tools that we have been talking about? Um, Google Cloud have what we call Google Cloud Operations Suite. Google Cloud Operations Suite consists of was basically grouped into two, and it's the operation focused tools and the application performance and management tools. So these two group uh, now have sub tools under them, and the first one is operation focused tools. Under the operation focused tools, we have the cloud monitoring, the cloud logging, error reporting, and service monitoring. We will see what all these things are doing in a bit. So these are the one that we have under the operation focused tools. And what they do is just to keep track of our application while they are running. We can know what is happening, what is going on, what is happening basically to the app or the system that we are monitoring. And the second one is application performance and management tools, which consists of the cloud debugger, cloud trace, and cloud profiler. And this particular one is mainly for us to debug, to troubleshoot, to check anything that happen when anything's happen, to be able to correct what happens to our system while on cloud. So the first one that I want to check out this time is cloud monitoring. And cloud monitoring, what it does basically is to check the health check of our system, and we can use it to configure alarms to set up alerts when anything goes wrong, whether there is high memory consumption, whether there is low memory consumption, there is downtime, there is service disruption. We can set up alarms, and anything that happens, we get an alert, be it through an email, through SMS, and any other method that we wish to do that. And apart from that, we can use our cloud monitoring to generate charts and graphs to be able to vision or have a clear picture of what is happening to our app or our system. And second one is cloud logins. Cloud login is basically it will help you to any all your system that you deploy into any environment on Google Cloud. Event they emit will be emitted into a log file, and that log file will help you to locate the root of any issue that happened to your system, and you'll be able to track. When you are able to track that from the log file, you can be able to fix it very easily. So what cloud login help you to do is just to ingest application system log data. So it help you to emit data that the data that, or let me say the events that is being emitted from your system that you deploy to Google Cloud, to help you to emit them into a kind of log file, and you can get the log file and trace any issue that happened to your system. The fourth one, the third one that we're going to be talking about is the cloud debugger. This particular one is application maintenance and performance tool under the Google Cloud Operations Suite, and it is basically to monitor application performance, and you can use to check the state of your application while it is in running mode. The running mode of the application, you don't have to stop it before you can use Cloud Debugger to check out what is happening to your application or your system, and your customer will not even know whether you are debugging your code on while in production, where you are checking anything, and you can use this particular tool to know how your code work in production. Um, Cloud Trace is basically to mostly use while you are working with microservices, and when you are working with Microsoft services and containers, where the component of your system are being divided into different chunks, and when there is an issue, will be very difficult for you to know where the issue is coming from. But with the help of Cloud Trace, it will help you trace out where the error is coming from, help you debug it, and fix any issue that comes into your system, and at the end, help you optimize your code. So Cloud Trace is a kind of tool that will help you trace out the problem when you are having a when you are designing your system to have a kind of chunk components joined together to become a system. So that's the work of Trace. So lastly, you have to measure everything. It means you keep track of everything that happens to your system, to toil automation, to reliability and health of your system. You need to know what is happening to them, and for you to be able to do this, you have to keep track of them using the monitoring tool and the observability tools that I've mentioned in the past. So fun fact about me, I've never posted a WhatsApp sticker nor watch an anime. And if you have any question about what I've talked about, don't mind me, I'm rushing because of time. um Drop me a chat on Twitter at IBN_MUDATHIR. You can tweet and tag me. You can send me a DM. I would love to hear what you feel about the presentation. If you don't have any question, take a snapshot right now. Take a picture, post it online, tag me, and tag the Devfest team of Bida. So if you like to check more out on what we discussed about today, you can check out this link. And if you have any recommendation, don't hesitate to reach out. Thank you so much for giving me the floor. Bye bye.